Take a moment and think about this. AI is just predicting what comes next. So, if your input is unclear, what do you expect the output to be? Most people think that the problem is the model, but very often it is not. The real problem is how we ask, and that is exactly where prompt engineering starts. Let us start simple. What is a prompt? If you think about it, a prompt is nothing fancy. It is simply the instruction or input you give to the language model. For example, summarize this document in 100 words. That is a prompt. Convert this into bullet points. This is also a prompt. Now, here is where it gets interesting. Not all prompts produce the same output. Even small changes can completely change the result. Why? Because these models are probabilistic in nature. They do not think like humans do. They generate the next most likely token based on the input you provide and the patterns learned during the training. So, prompt engineering is not about asking more questions, it is about asking in a better way. Now, let us go one level deeper. What is context? So, this is where a lot of people get confused with. Context is simply the information you provide so the model understands the situation it is working with and produce desired outputs. Let me give you a simple example. When you say summarize this document in 100 words and then you upload a PDF. Now break that down. The instruction summarize this document in 100 words is your prompt. The PDF that you attached is your context. So context is not something completely separate. It is part of the overall input. Think of it like this. Prompt tells the model what to do. Context tells the model what to work on. So far we have discussed prompt, context, and the difference between prompt and context. And this distinction becomes very important in real systems like document Q&A, RAG pipelines, coding assistants, and including AI agents. Now let us move into something more practical. You might have heard terms like zero shot, few shot, one shot, but what do they actually mean by? Short simply means example. Zero shot means you give the model no examples. One shot means you give one example to the model. Few shot means you give a smaller number of examples to the model. Now here is the important point. The model is not learning in real time. It is not updating its weights. It is simply using the examples that you provided inside the prompt to figure out the pattern for your request. Let us take the same summarization example. Here is a zero shot version. Summarize the document in 100 words. Format it as problem statement and solution proposed. Now, modern models are much better at following clear zero shot instructions than older ones. But sometimes the output can still be inconsistent. Now, watch this. Here is a few shot version. You give two examples first, problem statement, solution proposed, the format that you expected from the LLM output. And when you provide this prompt with few shot, now the output becomes much more structured, more consistent, and usually much better aligned. So few shot is not about intelligence, it is all about the alignment. As we now understand zero shot and few shot, here is a simple rule of thumb. Use zero shot when the task is simple and the instruction is clear. Use few shot when structure, tone, or consistency really matters. Now let us go deeper. This is where prompt engineering becomes much more powerful. What is chain of thoughts? Chain of thought, or COT, is when the model is encouraged to reason step by step before it gives the final answer to the user. Instead of jumping directly to the answer, it breaks the problem down. Let us take a simple example. A company has 3 teams. Each team has 8 engineers, and then 5 more engineers are joined. How many engineers are there in total? A direct answer is 29. With chain of thought, the model may say, let's break it down step by step and provide the final answer. Same answer, but now you can see that reasoning behind the model. And this is not just theory. The landmark 2022 Chain of thought research papers showed that generating intermediate reasoning steps can significantly improve the performance on arithmetic, common sense, and symbolic reasoning tasks of LLM. So, when a problem involves multiple steps, this approach matters. Now, let us move to something even more interesting, chain of draft, COD. This is new one introduced in a 2025 paper called Chain of Draft, Thinking Faster by Writing Less. And the idea is simple but powerful. Instead of writing long, detailed reasoning, the model writes only short intermediate drafts, just enough to capture the key logic, basically, like humans' rough work. Let us take a simple example. Jason had 20 lollies. Now he has 12. How many did he give away? A chain of thought style answer might say Jason started with 20 lollies and all the reasoning behind it. A chain of draft style answer would be much shorter. 20 minus x equals 12, x equals 8. Same logic, less words. This is the key and very interesting one. The chain of draft paper reported that COD could match or even surpass chain of thought or COT on several reasoning tasks, while using as little as 7.6% of the tokens. This is prominent one. For example, on GSM 8K benchmark, the paper reports GPT-4 were at 95.4% accuracy with chain of thoughts and 91.1% with chain of draft. So the accuracy is close. But the key thing here is the token usage drops massively. And that means lower cost and lower latency. So what does this mean in practice? Chain of thought is great when you want detailed explanation. For example, documentation or visible reasoning. Chain of draft is great when you want speed, efficiency, and lower cost without writing a long explanation every time. So the simplest way to remember it is chain of thought, detailed reasoning, chain of draft, compressed reasoning. Now let us quickly bring everything together. Prompt is how you ask. Context is what you provide. Zero shot means no examples. Few shot means a few examples for alignment. Chain of thought means step-by-step reasoning. Chain of draft means minimal intermediate reasoning. And all of this is really about one thing: controlling the model's output. Because at the end of the day, LLMs do not behave like human thinkers. They respond based on the inputs, patterns, and constants you provide. And once you understand that, everything changes. The next video, we will go one level deeper: system prompts and user prompts. This is what real-world systems like LangChain, LangGraph, AutoGen, everything builds on top of these ideas. If you want to truly understand AI, not just use it, this series is for you. Thanks for watching.